So welcome to the seventh Go Solis webinar of the year. We're very proud to present a new webinar for you today. We are going to be talking about testing Solis inverters beyond your certifications to bring that real-world reliability data to your commercial and utility plant developers. Big topic today and kind of a long title, I must admit, but beyond certifications, it's a real important part of this. You know, you can test things up to your certification level, but if you go beyond that, you start to really find out how strong, how reliable, and some of the failure modes that these kinds of equipment has. And then bringing that data to these developers is a really great way for them to reduce risk. We're going to talk about that, and a lot of great meat in this webinar today. Solis, of course, is a member of SEIA for a long time, and we really support the California Solar and Storage Association out there in California, doing great stuff out there. Me, Terence, with you today, and my colleague Gary Lam. Good to have you with me, Gary. And Michael Mills-Price, the head of the inverter and energy storage business over at PVEL. Really glad to have you with us today, Michael. We're looking forward to the presentation. Well, just to kind of go over what we'll talk about today, I'll just introduce Jinlong a little bit. And I want to get just a little bit into the regulatory environment here, because that is part of what's really pushing this need for reliability in inverters and all PV equipment, really. But and that's what Michael Mills-Price is going to get into here as he introduces PV Evolution Labs and what they're doing there. He's got some great stuff to talk about when in that relationship PVEL has with the global community downstream. I really want you guys to hear about that. And Michael's going to get into why we're really testing these inverters and the PVEL PQP, which is something I know you guys want to hear about. And then at the end, I'm going to have Gary talk a little bit about how we as a company are designing for reliability out there. We'll open up a little Q&A session after this is over. Jinlong Technologies is the name of the company I work for, and we produce the Solis Inverters. That's our brand name here in North America. You can see that we're certified around the world there, and you got a picture of my factory. Gary, I love that. We got PV all over that factory roof there. And we are now a publicly traded company listed on the Shenzhen Stock Exchange. 15 years of string inverter design history. And just a couple of fun facts. First Chinese PV string inverter to achieve the UL certification back here in 2009 here in the US. And we were the first inverter to complete the PVEL inverter reliability testing. So kind of proud of that as well. You might see those 4 little shields down there. That shows that we have been rated the top inverter by the EUPD the last 4 years in a row, 2016, 2019. Now, I want to talk a little bit about North America, though. Solis has offices around the world, but we have offices here in North America, and have gotten our lifetime analysis and bankability studies, along with a bunch of other due diligence AVL lists that we're on. But you can find our bankability report done by DGL, and I kind of like to point out one of the things they said in their report there, that useful life projection at or near the top. We'll take that every day. Well, let's get into this a little bit here. What's going on? Transition is going on here in North America. The NEC, for example, is changing quickly, and you're seeing a lot of the folks adopting even the latest code. We have one state already who has adopted the 2020 code, and many of the states are adopting the 2017 code. And in addition to the new safety measures and rules we're under with the National Electrical Code, we're also seeing a regulatory environment that's changing, that's improving really, and tightening up some of the interconnection issues that we're seeing. And I think it's going to lead to greater adoption of solar on the grid for sure. And there's many new standards that I think you folks need to start taking a look at. IEEE 1547, that's your standard for interconnection. And the 2030.5 standard is another IEEE standard that a lot of folks are looking at today for defining that default communication of inverters with their utilities. It's super important for the adoption of inverters coming up, but it puts a lot of pressure on us inverter manufacturers. You know, for example, that 1547 is accompanied by 1547.1, which is a functionality test for these new smart inverters that we are manufacturing. And it's a huge breakthrough. I mean, this is a big step forward. It's a way to validate that these instructions that we're sending back and forth will actually achieve the desired behavior in the system that we're looking for. It's really big. It's really showing that transition to that renewable energy economy, but it's putting some pressure on inverter manufacturers. We got to deliver reliability, and reliability isn't just about, you know, a solid piece of equipment. For the customer, it involves not only the equipment, but the manufacturer behind it that's building a design for reliability product, and the performance. It's got to be up to speed. Remember, we've got iPhone and Amazon connected folks out there, and they're kind of expecting a level of quality and performance from these new products. And, you know, that's really stretching, really, what we're trying to do with the best safety and the best interconnection, participation with that grid support. And all of that is really increasing the importance of evaluating inverter reliability and their performance. And really, this leads me up to introducing Michael Mills-Price from PVEL. And Michael, I'd like you to tell us a little bit about what the great work that you're doing over there at PV Evolution's lab. Michael?
Thanks, Terence, and Jinlong for this opportunity to speak today. PV Evolution Labs was founded in 2010 as a third-party independent testing lab, and really founded for a need to provide further information in regards to the product and project longevity. The primary focus is on testing solar plus storage products and really testing them to understand their durability, their resiliency, and how they're going to perform once fielded. Our biggest consumer of data is this downstream partner list, which we'll talk about in a little bit, but each of our individual programs are characterized specifically for that product. So you see here we have a product qualification program for PV modules. We have one that we're going to talk to today about inverters. We have them for batteries and for energy storage devices. This product qualification program is a comprehensive suite of tests really to shake out top performing products from lesser performing products. And we really intend to continue to revamp it based on the industry needs, as well as in line with some of the things that Terence has mentioned, which is inverters today have to offer more grid support features. We're coupling energy storage and PV into a common power electronics platform. And these subtle changes, or large changes really in the industry, help drive a testing paradigm to make sure these products can meet their expected life. In today's short presentation, we're going to talk a bit about the primary functions of PV inverters. At their base level, they are intended to convert DC to AC. But while they're doing that, right, they have to be able to interoperate with the AC grid and be commanded and controlled to these different operating points. We're going to talk about why we test inverters, specifically around some of the failure modes that we're seeing in the industry, and characterizing these failure modes, because different failure types, as an example, if inverter isn't communicating versus an IGBT failure, result in quite a different output and impact. I'll briefly walk through the product qualification program for inverters. There are some slight adjustments depending on if it's a micro inverter, a DC optimizer, a string inverter, or a large string inverter. And then we'll talk about comparing test results and how this data flows back to the industry. So one last graphic that we like to help introduce PVEL is this concept of downstream partner, which are the project developers, the power producers, the EPCs, and the financial community and institutions. And then on the other side are the equipment manufacturers. And PVEL sits right square in the middle. We are trying to help provide additional information to the downstream partners by connecting the PV equipment manufacturers with this buy side of the market. And as you see in the graphic, the equipment manufacturers sign up for product qualification program testing, individualized to that specific product. We test it through the program and then share those reports with the downstream community so that they can make comparisons to see if these products meet their forward strategy for their projects. And the downstream partners help us by continuing to encourage participation in the program. And at this point in time, we have over 400 downstream partners representing greater than 30 gigawatts per year of buying power. And on the equipment manufacturing side, we have more than 75 participating companies. So in this holistic landscape, PVEL is testing, again, modules, inverters, and storage systems, and they're getting access to this information, these project developers are, to help better pick products that meet their portfolio needs. So why test inverters? I mean, again, the primary role is to convert this available DC energy to AC output energy, doing this while abiding by the local interconnection rules and monitoring the grid side for safety issues. So that's kind of the interconnection tests that were mentioned by Terence when he talked about 1547. On top of this, and with these newer mandates for command and control, they have to provide data up in terms of how they're operating, as well as accept data commands down to go to different set points. Non-unity power factor comes to mind as an application. What I'm trying to say is these inverters are multifunctional, complex devices. They are hundreds or thousands of individual components put together, controlled by firmware, and trying to operate as an inverter in these unique landscapes. And different jurisdictional locations require different operations. So many times an inverter will have different modes it can be set in, depending on where it's being installed geographically and really electrically. They are the central communication and integration hub of a PV system. So the modules aren't providing data up, the inverter is providing that communication data based on its operating characteristics. Overall, they're the most critical piece to a PV power plant. So continuing this concept of why testing inverters, and I really like to make the comparison back to certification testing. So certification testing is typically performed on a single sample. So you have a single product provided by a manufacturer to a test body, UL, TSA, TUV, one of these test bodies, and it's really primarily focused on safety and integration integrity testing. So we're not looking at long-term wear out, we're not looking at midlife wear out, we're really trying to understand if this product is safe to be installed in a residence or a commercial operating facility. With a limited sample size, additionally, the opportunities to understand different wear out mechanisms by exposing these to environmental conditions is very limited. For the middle graphic here, a study completed by Sandia National Labs analyzing different portfolios of PV projects found that the failure was not closely correlated to specific manufacturers, product types, or system ages. So if we look at that graphic in the middle, there's 4 portfolio listed, A, B, C, and D. And these are sliced in different manners, whether they're utility scale or string inverter only or a blend of both, as well as an age of operation, which you see in column 2. And what we're finding is for 3/4 of these portfolios, or 3 out of 4 of these portfolios, inverters resulted in the highest #1 failure mode. So we had more failures of the PV plant to produce energy as a function of the PV inverter than any other component. Now, if we carry that up to the top right graphic, these are tickets counted in terms of failures. And we see that the inverter piece is 10x higher than the next major component in regards to system failures. So inverters at 1227, the grid is the next highest one at 109. Which just keeps to show that we need to continue to focus on this inverter piece, driving out these root failures through systemic testing. Now, not all failures are the same. And at PVEL, we describe a series of different failure types and what their impacts are. Because a communication failure may be such that the inverter can't communicate its current operational status up to the central controller or managing asset. However, the product could still be producing energy and in line with our expectations. And so at PVEL, we listed different failure types and impacts to help ease that ticket count that you saw on the previous slide, so we can really start to connect the dots between this failure mode could result in this type of economic impact or this type of service call. And what that does is allows us to break those large ticket counts in terms of inverter failures above and really truly try to understand the impact of that in-project asset life. Okay, let's jump into the PVEL Inverter Product Qualification Program. The testing data from the inverter PQP really is meant to help support modeling, warranty, and life expectancy. Now, we still assume that manufacturers are performing halt testing, HAS testing, and building up life models at the component and subassembly level for each individual inverter product. That said, the third-party independency here from our lab is testing these products as a black box. And so this data set should accompany the manufacturer's intended data set for this overall picture of bankability. We continue to design the PQP in response to market needs. And as I've mentioned a few times, as interconnection mandates change, as different products begin to blend, I think of hybrid inverter in that particular example, we continue to update our product qualification program so that it's relevant for what's happening in the field today. This update comes from our downstream partner steering committee, and together with other institutions, we continue to modify our product qualification program to meet current market needs, as well as the types of data that our downstream partners are looking for. A couple notes about the PQP. All samples to be tested are witnessed in production. PVEL or its affiliates will go to the manufacturing facility, do a factory audit, and sample selection at the manufacturing facility. So we physically pull samples from the facility, wrap them in tamper-proof tape, and have them shipped to our own lab. What we're doing in that process is ensuring that the products we test are the same as those you would buy off the shelf for commercial applications. Secondly, all inverters are tested using the same lab equipment in the same environment, which is overseen by our ISO 17025 accreditation. So what we're saying is, as we expose these products to these different environmental conditions, to these different electrical conditions, we're able to keep them and monitor them closely with research grade equipment and provide the utmost in terms of fidelity from our overall testing strategy. To date, we've tested more than 48 products from greater than 15 inverter manufacturers, and this spans a whole series of classifications, from microinverter and optimizer all the way up to large 1500 volt three-phase string inverters. So what are these product qualification program test sequences? And what I've provided here is a snapshot, a high level of different categories that the products will go through. Passive chamber testing is unpowered exposure to different environmental conditions. So prior to units going into any of these passive chamber tests, they get pre-characterized electrically, and then we put them in the stress, damp heat, thermal cycling, humidity freeze as listed here. And then we post-characterize the inverter products, and then we compare the pre and post-test electrical data to understand if things are beginning to degrade or fail as a function of that exposure. Similarly, for powered thermal cycling, we are operating the units from their minimum nameplate to their maximum nameplate ambient temperature and inside of their DC and AC capacities. But we're trying to push these products such that they are stressed in a function that could occur in the field, such that we can get faster accelerated turnaround lifetime data for each of these individual products. That includes high temperature operation, which is many times called dry heat, and low temperature operation as well. When we get in the performance category, this includes things like maximum power point tracking efficiency, conversion efficiency, and energy harvest. For the MPPT efficiency, we test to the PREN 50530 standard, where we're trying to understand the capability of the device to dynamically track the irradiance and temperature coefficients of the interconnected strings. Conversion efficiency and energy harvest are both additional tests that really allow us to understand how good is this inverter product at capturing the theoretical available energy on that given array. Moving to performance testing, AC operational window. The intent of these series of tests is to understand if products derate as a function of AC voltage, which includes the low voltage ride-through in many areas today, DC voltage, because there's a host of different stringing configurations for any given inverter, and transient response. How does the device behave under these transient conditions like low and high voltage ride-through and like low and high frequency ride-through? Lastly, as part of the PQP test sequences, we do install products in our field in PV USA and Davis, California, and we operate them for a minimum of 30 days while monitoring their capability to harvest energy and also respond to forced ground and forced arc fault conditions. Together, this PQP test sequence continues to provide a breadth of information on individual products from any given manufacturer. So what does all this mean? All this testing. Each individual product qualification program results in a technical report describing how the individual product performed relative to those test conditions, whether they be the environmental conditions or the electrical conditions on the AC or DC side. That said, in addition to the individual test technical report, PVEL released the first PV Inverter scorecard in 2019, which is a culmination and a high-level explanation of different tests performed, as well as some of the top performers in each of those categories. Again, the testing is meant to address early product wear out, mid-product wear out, and end-of-life wear out strategies, and to provide this data to help support warranty estimations, continuous product improvements, and resiliency mechanisms. It really allows you to compare different products from different manufacturers and even different products from the same manufacturer in terms of how those products should perform as part of your portfolio. So summing up my short section here, Inverters are and continue to be the #1 source of PV system downtime. And we hear that from multiple institutions, research labs, as well as our downstream partners. The PVEL PQP provides data set on device performance, operations, and resiliency. You can actually go to specific product level detail and exposure conditions, whether that be DC voltage, AC voltage, DC loading ratio, how it's going to perform at high or low temperature, and understand how that product is going to fit as part of your overall operating asset. The PQP testing strategy continues to evolve to keep up with today's changing regulations, as well as some of these new features and functions that some manufacturers are bringing to market. And lastly, this data is imperative to overall system performance, understanding, and really the economic modeling for each of these PV sites. And I'll leave it with that and pass it to Gary Lam.
Okay, thank you, Michael and Terence. So I'm going to talk about how Jinlong have proven reliability around the world. Since 15 years ago, we have been shipping to over 10 gigawatt to over 100 countries. And we have taken many approach to mitigate these quality issues. Michael have mentioned before, there's a lot of few issues on that we are commonly seeing. And it actually take a lot more than just checking the inverter at the final stage to do that. Jinlong, we have taken every single step into consideration from the very beginning design process and manufacturing, and finally, the commonly along the Q&A process. This is a inverter product line that we currently offer in the US. We offer a variety range of inverter size, anywhere from a single phase 2.5 kilowatt residential inverter to a three phase 1500 volt 125 kilowatt inverters. And also our newest Solis single phase storage inverters, which is a hybrid inverter that is capable to do solar plus storage. And of course, we don't miss our 25 to 60 kilowatt CNI rooftop inverter. Right? As I mentioned, QA is not the only step we take to ensure inverter quality. We design inverter with reliability in mind. As Michael mentions, there's a lot of failure related to field, fan, communication, fuses, AFCI. And so we have outlined them. The most commonly known issues are external fan. The fan need constant maintenance and repair or replace. And then fuses, sometimes might not be a fuse issue. It will be overcurrent, but also could have a chance of nuisance tripping, right? And then finally, a contaminations. Contaminations is like dirt and debris that get into the inverter due to air exchange type. So by mitigate how all these issues, the best way is to take it away, right? So we have inverter that have built-in advanced feature that do not require a fan, do not require fuses, and it will block all the contaminations from outside. Second, productions. From design point, we have think of what you will get out of the inverter. Obviously, we are all doing it for one purpose, is the gain, the money. So we have built-in yield optimizations, obviously support for bifacial, and how to ensure a maximum uptime with the technology we offer. And finally, the most also very important is how easy is it to use and operate. How quickly we could install them, how fast the commissioning could go, and how less we worry about it. Next is the manufacturing quality. How can we assure we build inverter to a quality product? Manufacturing is very important. We ensure automations will embedded into our manufacturing line. Using computerized automations, we have high accuracy, high consistency within the production line. And it also offers us an unparalleled flexibility. What does that mean is this minute, we could be building our single phase 2.5 kilowatt inverter. And then 5 minutes after, through switch of program, we could be manufacturing our 125 utility inverter on the same production line. And same concept apply to third-party manufacturer. When condition needed, we will be able to export our programming to a third-party contract manufacturer. And they will be able to produce Jinlong inverter with the same quality at their facility. Second, on choose of material, we have choose to take in the string inverter path by using a lot of semiconductor technology and components. The obvious benefit of it first is lightweight. It's very lightweight, right? Most of the semiconductor are small and compact. Second, with the very mature semiconductor industry, we have a lot of readily available components for us to select. They have been proven in history of reliability and power. Third, more importantly, using semiconductor, we use much less copper, which copper is getting more expensive material. And as semiconductors' main material is silicon, they are built from sand. With this aspect, we're able to control our future costs at much better weight. Also, using copper, it's also weighs a lot more. For example, while we're comparing to the traditional central inverter, which involve in a lot of heavy metals in there, including coppers, aluminum, steel, and others, they build up in weight very fast and increase the difficulty to work with. They are all hand built, manually built, and therefore a lot of failure could happen, right? The last, a long-term partner, just like you, any owner, EPC, installer looking for a long-term reliable inverter partners, we are also looking for the same quality partner in our supply chain. We only look for the most bankable company, which have proven the reliability and have a long track of record with Jinlong. A lot of suppliers that we currently work with have been supplying us components since the first day Jinlong has formed for the last 15 years. And they have proven their reliability in our product for the time being. And the last is the quality assurance process in our factory. By enabling automation manufacturing, we are able to take multi-step QA at the circuits level. On every circuit printing step, we will take a quality process to ensure the quality. For example, after components have been placed on the circuit board, we do an automatic optical inspections, AOI. And then second, we do selective soldering on components that require additional care, right? And then finally, at the assembly level, when the inverter are fully assembled, we'll do assembly QA with the electrical and mechanical characteristic. And finally, when inverter are ready to go, they 100% go through the Hall testing in the heat chamber. Yep, I think that is the presentations I have. I will get this back to Terence.
Thanks, Gary. I'm also very proud of the fact that we are the factory. We are managing our own quality and our own programs with our own equipment, and indeed that unparalleled flexibility with that equipment is being, of course, integrated into this new factory that we're opening up in 2021. That similar platform that we use across all of our products around the globe, that uniformity and that capability to manufacture different things, it really is a distinguishing feature, I think, along with that 100% halt testing of every product before it gets boxed up. Really two distinguishing features that we're doing to increase quality out the door. Thanks, Gary, for that. And with that, we have a little bit of time left, and I'd like to open up a Q&A session. We've got the whole team here, and we look forward to hearing some of your questions. Thanks for spending some time with us today. And Michael, do we have any questions coming through the chat line or any other way?
Yeah, it looks like we have a question here from Kyle Northway. If a utility requires an inverter to operate outside the range of the UL 1741 certification or IEEE 1547 standard for volt VAR, do you allow and do you have the ability? Do you all allow the voltage or frequency window to be opened up? What abilities do you have in the inverters to handle high distortion at the fifth harmonic?
I think I didn't quite get the full questions, but I guess the main question is regarding the inverter distortion and harmonic. So far, we have done harmonic tests to all our inverters as a standard. All of our inverter harmonic generation would not exceed 3% as the grid code allowance. Most of them are fairly low. And especially when we are using a string technology, the interference on the distortion is very, very low, much lower than central inverter.
Thanks, Gary. We've got a question for Terence. Is Solis participating in PQP now or in the future?
Oh yes, we're planning on putting our entire product line through the testing. Today we're in testing with our 125 and have plans to put more through testing in 2021. So yeah, we're fully engaged and believe in the third-party validation of our reliability and performance will, as I noted earlier in the webinar, reduce some of the risk and help with designers understand the functionalities of the product. So we're a big believer in third-party validation, and we'll continue working with PVEL.
Thanks, Terence. Looks like we got a question for Michael Mills-Price. How do PVEL and Solis work together?
Yeah, thanks for that. The typical process is as Solis develops products, gets them through the compliance sequence and gets the listing to mark, and then tools up the manufacturing line for production. Because again, remember what we said earlier, we require a factory witness and sample selection. So as those production lines get ramped up on that specific product category, we would then schedule to come perform the factory witness and then sample selection throughout that process.
Thanks for that, Michael. Another Gary question. I thought you guys were going to talk about the 75 to 255K inverters. Are you guys going to introduce them soon?
Yes, since this is the product that we will be introducing, and actually we have a marketing event, we'll be promoting this product all together globally. And so stay tuned for our next webinar. We will cover them in detail.
Thanks, Gary. Looks like another question from Michael Mills-Price. How has PVEL's inverter testing evolved over time?
Yeah, that's a great question. So as we mentioned with the downstream partner steering committee, we do continue to update some legs of our testing strategy to keep them relevant with new functions and features of inverter products, or as I mentioned earlier, as hybrid products. So we have this combination of kind of the storage and the PV together. In addition to that, there are many working groups around power electronics reliability, and we ensure that we stay close to those in terms of concept and what those wear-out mechanisms are that we're testing for. And that results in a yearly or every 18-month update to our product qualification program. Most of the time, those changes are pretty minor. They could be duration changes based on test data that we've seen over the last 18 months, but sometimes they include more major revisions to make sure that we're capturing that functionality. An example would be with California Rule 21 and low voltage riding, to make sure that we're addressing how these products respond under those types of scenarios.
Great answer. Gary, is there any difference between the 125 that you have today and the 255 that's coming out soon?
Yes, the main difference for them will be the first on the MPPT. The 125 kilowatt will be a single MPPT string inverter unit for a maximum design flexibility. And the 255 kilowatt will be a multi-MPPT for the ease of install and operations. And with dividing multiple MPPT, it will give you more yield and also eliminate the need for adopting any DC fuses. Other than that, the other majority functions will remain the same. Obviously, the 255 will be a newer unit, so we'll pack more of the advanced feature into it. Again, let's stay tuned for our next webinar that are dedicated to those new inverters.
Thanks, Gary. Looks like the last question here is, what Solis products will PVEL be testing in the future?
Well, I might be able to answer that. Yeah, like
Go ahead.
yeah, Gary, I think that we're putting practically our entire product line through there, aren't we, Gary?
Yeah, we are actually looking to continue to work with PVEL so far. With all the product we are launching, we are scheduling tests, field tests with PVEL, and we look forward to continue to do that.
Thanks, Gary. Well, looks like all the questions we have.
Yeah,
All right.
so I just received the full questions regarding the harmonic distortion and things. So let me just go back and answer most of them. So the first part is asking about UL 1741 certificate or IEEE 1547, and regarding standard for volt var. So we do allow volt var, and on the 125 we allow daytime volt var, and the 255 we have enabled also nighttime volt var. So you'll be able to adjust the volt var you need during nighttime. That's a plus. In terms of the daytime volt var, the inverter is fully capable to do a 0.8 to 0.8 lead lag volt var. And also regards to, it was quite a long questions from Kyle. Actually, do you allow voltage or frequency window to be opened up? Yes, we do. So the voltage and frequency window are configurable through the inverter internal software. We have preset the US grid code, the voltage and frequency window for US grid code, but it is adjustable as and customizable per different utilities requirement in different regions. Okay, I think this kind of question sometimes I might not be able to explain briefly, but feel free to just send in an email if you're looking for any of these technical questions. We could discuss in detail that way.
Yeah, we look forward to talking about the new products that we're introducing. There's, as Gary noted, there's a lot of new features that he can't get into completely right now, but the webinar will get into some of the excellent anti-PID and other excellent features that these products are introducing. Again, I want to kind of wrap this up a little bit by going back to that title and talking a little bit about what we just were really covering today, and that is going beyond certifications in your testing. As an inverter manufacturer, it's informative to us to have third-party group push our inverters beyond what's required by UL or certification testing. It really exposes maybe some of the field conditions that we might see that we're not necessarily anticipating. But by putting it through a test regime that it's very close to, Michael, would you agree with us that the test regime is really close to what you do with PV modules, with the humidity freeze and the damp heat, dry heat, that sort of thing? It pushes this very complicated product very similarly to the way that we're pushing on PV modules that are expected to be up on the roof, exposed up there. I see some similarities in those testing there, Michael.
Yeah, that's certainly the case. We're trying to expose them to different environmental and voltage and AC voltage and DC voltage conditions to help understand how these products could wear out over their expected lifetime.
Indeed, and some of the tests that we would do in the factory are, let's say, a bit gentle. We'll ramp up slowly and we'll ramp down slowly. Whereas, when you're really pushing some of these things, you want to ramp up quickly or do a little distortion of and that's the kind of thing that these sort of third-party testing labs will do and hopefully validate and reduce risk. Because, and indeed, I guess that's my last message here, is that these kinds of testing that that PVEL can perform on a product like this will reduce your risk as a buyer or as a designer in understanding that this product is going to do what it's supposed to do and will continue to do it over time, keeping your OPEX numbers low. And that's really what we're trying to do here. As Gary said, our objective here is to ensure that the cash flow continues, and designing for reliability and ensuring that your product is reliable, validated by a third party, is the kind of thing that we hope will inspire and provide confidence to folks looking at these new products from Solis Inverters. I sure appreciate you spending some time with us today. I know time is valuable, and it's summertime. People are getting their PV systems starting to get installed now, and we all hope you're safe and healthy. And thank you again for joining us. Michael, you want to say a last word to our audience?
Just thank you for the opportunity to speak.
Thanks, Michael. Really appreciate you coming with us today and talking about PVEL. Gary, any last words?
No, thank you again, everyone. And again, if you have any technical questions, feel free to just email us so for a detailed response to them.
Indeed, and that's you can see our contact information there on the screen. Please do not hesitate to give us a ring or contact us via email or chat or text, any way you like. We look forward to hearing from you. And again, have a great day, everybody. Thanks for spending some time with us today, and keep that solar flying. Bye-bye, everybody.